Hi, my name is Seth Whitcomb, and along with Alex Evenson, Jonathon Hoffmann, and Trevor McMillin, we were assigned the automated table saw for our senior design project. Our mentor was Dr. Ali Amiri, and our sponsor was Horn Plastics Incorporated here in Fargo. Here you can see the current process that is being used to cut these small tubes used in manure spreaders. As you can see, it's a very dangerous process as the operator has to have their hand right next to the operating table saw. For our design, we chose to use 1x3 steel tubing and 1.5 inch angle iron to make the frame for the hopper. 80-20 and 80-20 bearings were used for the feeding carriage and saw carriage, and 1/4 inch plastic sheets were used for the hopper's sides. We also used various 3D printed parts to make this project possible. For our finite element analysis, we decided to analyze both the hopper frame and the sides of the hopper because these would have the most deflection. It was found that the hopper sides have a factor of safety of 4 and the frame has a factor of safety of 6. Here you can see the hopper frame being TIG welded together using that 1.5 inch angle iron and 1x3 steel tubes. Here you can see the plate that holds the bearing and motor for the rotating shaft that feeds the tubes into the hopper being cut with a CNC plasma cutter at NDSU. Here's a video of our final assembly. So the tubes will be placed into the hopper. Then the shaft will rotate to drop one pipe down in between the feeding carriage, where a linear actuator will clamp that onto another V-block. That will then be fed into the feeding carriage. In its current state, the system is able to cut 460 to 480 finished parts per hour. This results in just under 4,000 finished parts in an 8-hour workday. Additionally, this fully automated system removes the safety risk of the tubes being cut manually on the table saw. Additionally, a higher torque motor would allow feed rates of the saw to increase, which would further improve the finish of the cut and improve the overall cutting time of the system. We would like to thank the NDSU Mechanical Engineering Department, Dr. Ali Amiri, Jeff Harstick and Jesse Volosky at Horn Plastics, Project P for their 3D printer help, and Frank in the machine shop for his help also.